we come to the next speaker, Mr. Pramod Kumar, who's the DGM-FCC Corporate R&D HPCL. Mr. Pramod Kumar is the DGM-FCC Corporate R&D at HP Green R&D Center, Hindustan Petroleum Corporation Limited. He has more than 21 years experience and has completed his master's in chemical engineering from IIT Kanpur. His areas of interest are FCC process design, research, engineering, and technical services. He is also interested in research in the areas of biofuels and crude to chemical. Mr. Kumar has to his name more than 20 granted patents in India, US and EP. He has bagged the Product Innovator of the Year in Petrochemicals Awards in the year 2019. Other awards that he has won is Best Indigenously Developed Technology for Spray Max Feed Nozzle, Center for High Technology, CHT in 2017, HP Catalytic Whiz Braking Petro Feed Innovator in 2016, and Best R&D Project for HP Catalytic Whiz Braking Golden Star Award also in 2016. We welcome you, Mr. Pramod Kumar. Over to you, sir.
Thank you, ma'am. Can you give me the access for sharing the presentation?
Yes, sir. We'll be giving you the role.
Sir, we already given, sir.
Okay.
Yeah, you can share now, sir. You can share now.
Is my slide visible?
Yes, sir. It is visible.
So good afternoon, all. So first, I thank the organizer for giving me the opportunity to present our work, and thank to my management for giving an opportunity. And I also thank my previous speakers who have set up the tone for the talk, because all data and everything were shared. So I will take you a little more about the technological aspects. So the talk of my presentation is new age trends and innovation in refining and petrochemical industry. So the content of my presentation is challenge in refining industry, energy demand, refining capacity and fuel demand projections, refinery petrochemical integration and crude oil to chemicals, new age trends, and what HPCL developed technologies and products are there under such portfolios, and the end of the presentation. So if we see the challenges in the refining industry, we have a challenge on the strengths because the crude prices keep on fluctuating. So under such conditions, what needs to be done? The another challenge is about the environmental impact, because the qualities of the products like diesel and petrol has to be improved with respect to the sulfur, olefins and other things. We all know about this. Then down the line, we have an advent of electrical vehicle, which is again giving a challenge to the refining industry. Another challenge is coming from the renewables like solar, bio, plastic circularities and other things. Then our next challenge is about the futuristic transports like the hyperloops and all. So under such circumstances, what the refining industry has to do, we'll dwell upon in the subsequent slides. So if we see the energy demand projections, basically these data are taken from certain reference. Like 2020, we have this oil demand is around 30%, but if we see by 2045, the oil demand is still in the 28%. So broadly, what I'm trying to say is the oil and gas demand is expected to maintain its largest share in the energy mix till 2045. So there is, as such, there is no concern. But if we see the other things like the other renewables and the biomass are little up going up. Now, in terms of the various sources of this fuel, if we see, basically oil demand is trying to reach plateau by 2035. If we see these data, and renewable energy growth is to pick up momentum after 2025. That's what we are seeing, biomass and the other renewables. Sorry. Something went off, looks. My slide is moving, it got hanged up, looks like. Yeah, sorry. Yeah. So the next is about the distillate capacity demand. So mostly we are saying the distillate capacity demands are coming up into the Africa and the other Asia Pacific, that is mostly in the developing countries. Now, if we see the sustained product specification in the long terms, so the secondary unit capacities are mostly coming in the desulfurization, then octane and conversion units. Now, if we see the fuel demands, the transportation sector still consumes 50% of the refinery products. And if we see the IEA forecast, by 2035, the fuel demand is expected to reach plateau because of the stricter regulations and the penetrations of the EV. And in such situations, the refiners are forced to produce high margin chemicals. So that's what our previous speakers have told. There is a huge demand of the petrochemicals, and that now the keywords or the buzzwords is about the crude to chemicals. So we will be talking in the subsequent slide about those things. So basically, these are the few data. Like if we see that chemicals growth, it is higher than the GDPs, and if we see the chemical growth in the Asia Pacific, it is much higher than the other developed countries. This again data shows about the growth profile of the ethylene and the propylene, which has been talked by my previous speaker. So I'll not dwell much upon these parameters. So only we are still saying that ethylene, propylene, and the paraxylene demand is still more in the country. So this is the per capita consumption, like the average per capita consumption is 30. But if it's in India, it is less than 10. So there is a significant demand of the petrochemicals in the country. And as has been told by my previous speaker, every year the petrochemical plant of almost like 1.5 MMTPA has to be put up. So this again shows the same data, like what is the gap by 2025 and 2030. So these data I am not dwelling. I'm still straight away coming to what is there for us to do in these areas. So this is again like there is a talk of refinery and petrochemical integration and crude to chemical. So this left data shows the petrochemical yield. If you see the typical refining, only the refinery, the petrochemical yield is around 5%, because that petrochemical yields like the propylene comes from the FCC. And in FCC, the VGO is the main feed, which is, let us say, around 30%, and 20% maximum we can get the propylene. So it is around 5 to 6% in the typical refinery. If we go little more integration, like putting polypropylene, propylene recovery and polypropylene plus BTX, we can reach up to 10% of the petrochemical intensity in the refinery. If we put some petrochemical like PX complex and all, we can go, and along with the high severity FCC, we can go up to 20% of the petrochemical yields. Again, if we go to the refining plus paraxylene plus the naphtha crackers and the gas crackers, we can go up to 40%. That's the maximum. If we see like HRRL or the new complexes coming up, so we can go up to 28 to 30% of the petrochemical yields. Now beyond 40, what is the way out? The people are talking anything more than the 40% on the crude is called as a crude oil to chemicals. That's the complex people are talking about. So this slide shows about how the evolution of the petrochemicals has evolved. So this is the stage 1, which is pre-90, wherein the yield of the petrochemical is less than 50. Now between 90 to the 2000, the yield has gone up to 25% with the forward integration of the steam crackers. Then on the scale and the portfolio complexity, like deep FCC units, then paraxylene and paraxylene plus olefins, people have reached up to 40. Now beyond 40 is what we are talking, that has all happening after 2020, and which people are claiming about in the range of 40 to 80%. So these slides basically shows the typical refinery configuration. Like we have the refinery, then there is a naphtha cracker and the aromatic complex. So based on this, the different streams like ethylene, butadiene, benzene, toluene, xylene, and propylene can be obtained. So the right slide, basically very small one, but we can see basically what I'm trying to say is FCC typically makes around 7 to around 7 to 8% of the propylene. But if you go to the high severity FCCs, so we can go up to 20% of the propylene. So that's what the role of FCC comes into the refining industry, to make the higher ethylene as well as the propylene. So if we go for the high severity FCC, the total light olefins yields, including ethylene, propylene, and butenes, can go up to 40% vis-a-vis the conventional FCC which is there in the refinery, which produces 14% of the olefins. So this slide basically shows how the worldwide, since we have talked about there is a growth of petrochemicals, the refinery has to move towards the petrochemicals because the demands of the transportation fuels are coming up down. So in that such scenario, how the world is moving, so we will be talking in these slides. So the one easiest option is to go for the high severity or the high olefin FCC. So the typically propylene yield can go up to the 20%, and the feed would have to be a very light VGO feed. The second integration which is doable is the refinery has to go for the petrochemical complex integration, which means like high severity FCC plus the naphtha cracker or the gas cracker, and upgrade the same in the existing refinery configuration. So basically it's a refinery plus petrochemical complex which can go give the petrochemical yield up to 40%. Beyond 40%, what we are talking is direct crude to chemical. That means the crude can be taken, it can directly produce the chemicals. There are different ways. One is steam cracker, which is in Singapore by ExxonMobil, which has been commissioned. They take the crude and they produce directly the olefins like ethylene, propylene, and butane, and the claim is around 30% of the olefins can be produced. So it is a single unit configuration, but of course it's a thermal process. Then there is a catalytic cracking like FCC kind configurations which can make the higher olefins in a single step. Then there is a hydrocracking and steam cracking integration. So those things can make more than 40% of the olefins and the BTX yield from the crude. So this is the summary of the different pathways like which can give higher olefins and the aromatics. So the top one which I am showing, it takes the crude oil like which all OMCs and the other companies are having. They have the refinery, then in that they keep on adding the configurations like aromatic complex, steam crackers, which can give the higher yields of the ethylene and the propylene. The next is the direct crude oil can be taken in the steam cracker and can produce ethylene, propylene, and the butadiene. But the limitation of this technology is it can only take the light crudes. Next is the COTC complex that can take the mixed crudes having the steam crackers and the aromatic complex that can make the BTX and the higher ethylene, propylene, butadiene. The next two technologies which I am talking, the licensors are like Aramco, Lamas, CLG. Another licensor is Aramco, Axens, and the Technip. They come up with the two things. One is the thermal crude cracking to olefins. Second is the catalytic cracking of the crude to the olefins. And their claim is either using the thermal route or the catalytic route, they can make more than 70% of the petrochemical feedstock. So normally we know, like if you see in a typical petrochemical complex, the feedstock is mainly coming from the naphtha or the gas, and the typical yield of the naphtha and the gas is around 15 to 20%. So the cracker capacities are like 1.5 mmTPA. But what we are talking about the crude to chemicals, where the capacities, if you see, there are various references like Hengli in China, Jianging, Hengi, then Zhejiang and Shandong. The capacity you see the crude chemicals, 20 mmTPA, which we have the refinery capacity. So COTC complex are itself coming up such size, which is like beyond, like we were thinking about 1 to 2 mmTPA. These are all going towards 20 mmTPA COTC complex, which are running in China. And if you see the yields of the petrochemicals based on the crude oil directly, it is more than 40, even 50 to 60% yields are there. Even the latest Aramco and SABIC has announced their JV for 20 mmTPA complex. But these technologies, what COTC I am talking about, this basically are a integration of available technologies in such a way that it produces more than 40% of the petrochemical yields directly based on the crude oils. And the investment figures we are just, you see, these are all like within the like range of if such capacities of the refineries are being set up. So now what is beyond this? One is the COTC. Now beyond COTC, what we'll see in the subsequent slide. So now COTC we have seen in the previous slide that talks about the integration of the many units. Now this is the one reference from the literature where they talk about one pot configuration. Like there will be only one reactor which will take the crude and will make the petrochemical. So this is a literature which talks about the 30% yields of the olefins. And there is water co-feeding and other things to take care of the higher coke yields. Now in HPCL R&D Center, we have also developed a single step process wherein we directly take the crude and it can produce more than 40% of the petrochemical yields. That means olefins and the aromatics. And this process has been patented. So basically, and we are scaling up this process to put up a demo plant. So the advantage of this process is that there will be not CDU, VDUs, FCCs and all. This will be one unit which will directly take the crude in one unit. It will produce the petrochemicals. Yes. So next we'll talk about the other areas. That's about the decarbonization, and our previous speakers has all talked about like our COP26 meet. What is that country has to achieve net zero in 2070. So these are all data. I will not get into much into these data because these are all available. People may be knowing about these data. Straight away I will come to the what are the key things into these areas, what people are doing, and HPCL R&D where we are doing into these areas. So if we see the new trends, basically we are all talking about carbon neutral refinery. What that means is that we are all talking about CCS and all that CO2 has to be captured from the refinery emission. And there are a lot of like commercial units are coming up, even HPCL also, like we are also putting up a demo plant for capturing the CO2 in the refinery. There are other ways like people are converting CO2 to the fuels and the chemicals. We are also working into that, and we are trying to convert the CO2 to the olefins as well as the methanol. Hydrogen production from the methane without CO2. So if we see in the refinery, basically we have a well-known SMR process which produce the hydrogen, but in the course of producing hydrogen it emits CO2. So the data is like to produce 1 ton of the hydrogen, almost like 10 to 11 tons of the CO2 is produced. But in R&D, we have working in a process, developed a process at the lab scale, and we are trying to scale up this. Wherein, if we take the methane or the natural gas, it converts the hydrogen and there is no CO2 production. So it's a CO2 free process. Whatever carbon is there, we are converting that carbon into the carbon nanotube. So that process is now being scaled up. We are also working into the process for water splitting to the green hydrogen. Those are all under different scales of the lab development. And there are various like research we are doing in the energy efficiency through the process enhancement and the different chemicals and the additives. So the next is about the renewable energy. That's another way to decarbonize our sector. So HPCL, we know like it's the only OMC which produce 1J ethanol, and we have the 2 plants running in Bihar. Then 2G bioethanol from the agricultural waste. That's a lot of technologies, and the plants are being come up in India now. We have our own process, we call it HPSF, that is a steam assisted single step process, which is now being developed, and we are scaling up this process towards putting up a demo plant. Then we have also developed a CBG process, which is now, there's a lot of talk about putting the CBG plant. We call it a HPRAM, that's a rapid acid methane production technology. We have the pilot plant which consists of this, which can take this basically your biomass, and we have this our CBG, VPSA technology to purify this gas. Another area where we are working into a trijet, that's the used cooking oil can be converted to the ATF. This technology is now ready for a demonstration. We are doing the engineering to put up the demo plant. Then another is a drop-in fuel, like biomass. We can convert either into the gas or it can be converted into the 2G 2G bioethanol. But there is a process where we can do the hydropyrolysis and convert that into a drop-in fuel. That means it can produce gasoline and the diesel, and which can directly be used as a fuel. So there also we are actively pursuing and developing these technologies as a lab and the pilot scale. So if we see it down the line in the near future, so if you see the traditional refinery, it will have crude oil, it will have power and produce the conventional chemicals and the fuel. In the future, wherein we are all talking about the low carbon refineries, there will be feedstock coming from the pyrolysis, plastic oil or the biomass, gas can be used, water can be used to produce the hydrogen, and we can have e-fuels, then CCS. So all this integration will go into the future refinery where we can look out for the low carbon refineries in the future. So this is just a crisp of the innovation at HPCL R&D we are doing in terms of the technologies and the fuels and the catalyst and the bioproducts. I'll not go too much details because these are all available in our website. We can look into these technologies. We are also further working into the different chemicals which are used to improve the efficiency in our refining process and the petrochemicals. These are all available in our websites. But the main thing, like 2-3 technologies and the products, I'll subsequently discuss, which are related to the improving the petrochemical yields and the decarbonization. So one of them is the HP2FCC technology. We talked like in the previous slides, people are going towards the high olefin FCC technology. So at R&D, we have developed a process we call HP2. That's the Hindustan Petroleum high propylene FCC technology. The left side shows the pilot plant we have. This technology basically consists of a proprietary hardware and the catalyst. So this catalyst and using this technology, we can produce more than 20% of the propylene. And the best part of the technology is that it doesn't produce any residue, unlike the existing high propylene FCC technology, which is available in the world now. So this technology has the hardware and the catalyst. The catalyst has been successfully demonstrated at our refineries and HMEL. For the technology, we are trying to look out for a location and the capacities wherein these technologies can be demonstrated. So for these technologies, we have got the patents and awards for developing these technologies. I think my slide got a little hanged up, just one. Yeah, so I think my slide is visible. Can somebody confirm?
Yes, sir. Yes, sir.
It is visible. Yes.
Yeah, sure. Yeah. So we have another technology which we have developed is de-aromatized kerosene. So it is basically a conversion of kerosene to the de-aromatized solvent, and it uses a fixed bed reactor. And this catalyst has been developed by us. It produces basically 2 grades of the de-aromatized kerosene. So for this technology, we are putting up a demo plant of 52 KTA at our Mumbai refinery. The plant is under now installation, and by end of this year, we will be making this unit on stream. So that will produce the 2 grades of de-aromatized kerosene, which is a key demand in our upstream industry as well. So next, we are all talking about the blue hydrogen. We produce this gray hydrogen in the refinery, and if we capture that CO2, that is called a blue hydrogen. Now, this is a high gas technology that works on the process intensification, wherein like a big column can be like 22-meter columns can be reduced to 1.5 meter, like a rotating device. So these we have commercialized at our Vizag refinery for the fuel gas like H2S removal. So based on this technology only, we are now trying to capture this CO2. So this technology is under now engineering stage, and we will be putting up to capture around 3 tons of the CO2 from the HGO unit that may go on stream in another 2 years. So that's the another approach from the HPCL side we are putting up to decarbonize the sector. So in summary, we are seeing the fuel demand is going to reach plateau by 2035, but there is a hope. The hope is that we have to convert the crude to chemicals. So either it can happen through the integration, or we have to look out to put up a standalone plant. Now, of course, the crude to chemical is the need of the hour, but there is not a single solution for each for all refinery, it depends on the configuration what we have in the particular refineries. Basically, for the naphtha centric and the diesel centric, the configurations would be different. For the naphtha centric, it can be a cracker and the FCC thing. But for the diesel, it can be a resid upgradation unit followed by the crackers and the reformers. So the existing refineries has to shift towards the configuration to the petchem with the addition of the CCS things. And the COCT is expected to impact the petrochemical industry. Right now, we are all talking about 15 to 20% of the petrochemical yield from the integration, but the COTC can directly take us toward the 70 to 80% of the petrochemical yield from the crude. So that's the shift and the change will happen. And in the future, instead of having the integrated so many units, single step COTC is a possible solution for the refiner if you want to produce 60 to 70% of the petrochemical directly from the crudes. In the future, we are also believing that biosource and the plastic recycles, what our previous speaker has talked, can also go into the COTC complex to make it little more CO2, less emission technologies and the refineries. So with this, I come to the end of my presentation. So this is the administration building of my our HPCL R&D center. So thank you all for patience hearing. I'm ready to have any questions or the discussion. Thank you.
Okay, sir. Thank you, Mr. Pramod. We'll take the questions at the end of the session. And just touching upon few points, you had mentioned that oil and gas energy demand is up to 2045, and we'll be seeing some plateau or something by 2035. That's good. At least we have some time to look into it. And there is a focus more on crude to chemicals, 40 to 80% refining segment that you mentioned. Two things that you mentioned was, say, refinery petrochemical complex, a COTC complex, and upgrade in the existing refinery configuration. I think maybe the industry can definitely look into it, upgrading the segment and looking into a better refining solution. And then you were giving information about worldwide how COTC is being implemented. So I think already a lot of information is available, a lot of knowledge is available. The industry can definitely, as a country on the whole, we can look into it. And thank you for sharing a lot of information about HPCL, in terms of the innovations the company has done, the processes that they are following, and how, as an industry, we are going to move towards low carbon refineries. That's a very good point that you raised. And even green hydrogen technology, energy efficiency, even 2G bioethanol. Bioethanol is definitely a bigger focus in India. We see a lot of news coming in that segment, and how in the future we will be looking at single step of COTC, and maybe as an industry collaborative effort, this can be a possibility. Fine, sir. Thank you so much, Mr.